Hello everybody. Today we'll be discussing about uh, a program on hash table. Hash table is a kind of data structure that is similar to array but is still efficient in accessing and insertion of a particular element into the array. So here in hash table, the insertion is based on a hash function. So in our program we used a hash function as I index is equal to the inserting data modulus size. So if we are trying to insert 4, then 4 modulus size. Since this is an array of 10, 4 modulus 10 is 4. At 4th index, the 4 will be added. And now if we are trying to insert 14 or something, again 14 modulus 10 is 4. So at 4th position we can't insert since 4 is already there. So what we do is, it search for the next free space. We initialize the array as -1 initially, and we check for the next position where it is -1. And if that is found, the corresponding 14 is added there. And let's see the code. So here we declared an array named as hash of 10 with size 10, and we created a function called insert to insert the value data. And here is the hash function assigned to a variable I for indexing. So data modulus 10, that is the size, is assigned to I. So here in while loop we give two conditions as hash of I not equal to -1. So if it is equal to -1, that means there is a free space. In this context we said that if the value in the array is -1 or -99, that means the space is free, we can add any more. So if it is not equal to -1, we have to increment the value of I the way we incremented in a circular queue and all. And we also have another condition set as c less than 10, and c will also be incremented inside the while condition. C is initially 0, c is to count. So if we iterate searching for a free space, and if the count reaches 10, that is the size, there is no meaning for counting further because we completed a cycle. So we can terminate from the while loop. And this statement, if hash double equal to -99, this will be explained when we see the display part. So if we find that there is a free space, then uh, if there is a free space, the while loop will exit due to the failure of this particular condition. So the c will not be equal to 10. At that point, the hash of I, there is a free space. At that I, we can insert the data. Else, if the while loop is exited due to c equal to 10, then we say that the table is full because a complete cycle is over. So further insertion cannot be made. And on deletion, we see that the same strategy is used. We try to delete an element through the finding its index. So the element to be deleted is d. So it is supposed to be at d modulus 10. So we check whether d modulus 10 is equal to d modulus 10th index of hash array is equal to d or not. If it is not, the while loop is activated for iteration traversing from the next index onward. And here also we have a certain function called as c less than 10. So it is to count whether a complete cycle is over or not. And if we encounter a -1, that means the element will further be not there, because at our insertion we had seen that if we have seen a -1 after the point of the hash function, we can insert the element there. So if we are trying to insert d, and if there is -1, surely d should go there. So if there is no minus 1 at searching, we'll continue it. If there is 1, that means further we don't need to search more, so we are returned. And if the while loop is exited uh, because of c equal to 10, alright, then that means a complete cycle is over and we have not found the value d inside the array. That means element not found. Or else, if the while condition is terminated due to hash of I equal to d, that means we found that element, and then we can assign the value of hash of I equal to minus 99, displaying that hash of I is deleted. So we initialize hash of I as minus 99, and we have seen that if it is equal to minus 99, we can break the while loop. So here minus 99 says that after deletion the space is free, so we can add further. So that's why here at insertion point, if it is equal to minus 99, we break and we check. At that point c will not be equal to 10, so at that point we can insert the data there, so there is a free space. And on display also, the display is common to how we display something in an array, elements of an array, using a for loop. And this is a menu driven program, so here we have everything for insertion, deletion and display. And the most important part, we assign or initialize every element of the hash array to be minus 1 initially, stating that these are free spaces. Alright, and now let's run this program to check. Yeah, it is compiled successfully. So we are trying to insert one value, say 1, and now let's try to display it. So 3. So we can see that here 1 is present, and we are continuing it. So we want to further insert, and we are trying to insert 11. So here 11 is all 11 modulus 10 is also 1, so collision occurs and next free space is minus 1. So at this minus 1 or index 2, 11 would be placed. Let's see that. Yeah, after 1 at index 2, 11 is placed. And now let's try to insert 3. Alright, and we'll display it. So 11 1 11 3 is there. And now let's try to delete some element. Let's try to delete 11. So it will first go to 11 modulus 10, or that is 1, and then since 1 is not equal to 11, it will search for the next and it will see 11 here, and the 11 will be deleted and there minus 99 would be placed. So delete, and 11 is to be deleted, and 11 is deleted, the message came. Now let's display what is there. Instead of 11, now minus 99 came. Now let's see whether we can insert anything at that point or not. Let's continue, and we will maximize this. Okay, and I want to insert, and say at index 2 I want to insert 2, and now let's display it. So here we have 2, and now let me try to delete everything whatever is there. So 2, I want to insert, delete 1 is deleted, continue. I want to delete 2 is deleted. Now I want to delete 3 is deleted, and now I want to delete something what is not there. So let me try to delete 5. It will say that element not found. So this is it. Hash table is working successfully and very well. Yep, that's it. Thank you.